Hey guys, thanks for joining me for math. So today I want to talk to you about multiplication, partly because you guys have gotten really good at it. You brought your fourth grade math skills with you, and I want to help you bridge those fourth grade skills into fifth grade. All right, so if you'll notice at the top, I have the same multiplication problem written twice. And there's a reason for that. I'm going to show you two different ways we can use to solve that. The first one is one that you guys have been showing me. It's the area model. So I'm going to use the area model to multiply 36 times 54. I can see I've got two digits here and two digits here, which means I need to set up a 2 by 2 box. All right. There's my 2 by 2 box. I always try to make these ones a little smaller so you can see that I'm multiplying. This one is going to be a 10 or a tens by tens. This one will be a tens by 1. This will be a tens by 1, and this will be a 1 by 1 when I'm talking about the place value. So let me show you what I mean by that. I'm going to start with my first number, 36. I'm going to break it into tens and ones. So 36 would be like 30 and 6. 30 plus 6. And then the next number, 54, I can do the same thing with. I can break that into 50 and 4. Got it. All right, now it's time to start actually doing the work of multiplying. In this first box, I'm going to multiply 50 times 30. So I've got 50 times 30. Now to multiply those, you'll remember I'm going to first look at my first digits and say, well, 5 times 3, that's 15, times 10 times 10. I've got those two zeros in there that I'm multiplying, so I'm going to say times 10 times 10. I like to say times 10 when I multiply, when I put those zeros there, to remind me I'm not just adding in a zero. I'm bumping it up a place value by multiplying by 10. Let's do the next one. Now I'm over here, and I'm going to do 50 times 6, because I've got 50 and 6. I can use that same strategy. 5 times 6 is 30, and I only have one zero, so I'm only going to multiply by 10 once. 300. All right, let's take a look at this next one here. This is going to be my 4 times 30. 4 times 3 is 12, and I've got one zero, so I'm going to multiply by 10 one time. And then over here, I've got 4 times 6. And 4 times 6 is 24. I've now done all the multiplying work. If you'll notice, I had a 2-digit by 2-digit number, which means that I have 4 different times that I had to multiply. Now I can take all of these and add them up. Now these pieces are called partial products. Partial means it's only part of something, and products means that I multiply two factors together. So I'm going to add up these 4 partial products, and I like to do a little check mark by them when I write it down so I don't miss any. All right, so I've got 1,500, and I've got 300, and I've got 120, and I've got 24. Add it all up. I'm going to use my line strategy. I like to draw a line straight down as I add so I don't get off. 0 plus 0 plus 0 plus 4. 0 plus 0 plus 2. 2 plus 2 is 4. 5 plus 3 is 8. Plus 1 more is 9. And 1. 1,944. Now, a lot of you are thinking, I already know how to do that, which is awesome. But I would like to show you another way. So this one we call the area model. I'm going to write that right here. Area model. We're going to use a different strategy over here called partial products. You can think of partial products like a stepping stone between the area model and the standard algorithm that we're going to be working on later. We want to move toward this more sophisticated way of doing multiplication because the area model is nice, but when I start multiplying 3 and 4-digit numbers, I'm going to be glad that I have a more sophisticated strategy. I'm going going to start by setting up my problem, and let me show you how I do that with partial products. When I do partial products, I write my two numbers right on top of each other, and I line up the ones place. I'm just going to set it up just like this. It almost looks like I'm going to add them, but I have my multiplication sign here to remind me that I'm not. All right, so the first thing that I'm going to do is I'm going to look at this 4, and I'm going to multiply it by the first digit. So I'm going to say 4 times 6, because I'm going to go 4 times 6 straight up. I might even make it a little bolder. So 4 times 6 we know is 24. The next thing I'm going to do is I'm going to take that 4 and I'm going to multiply it by the 3. But here's the trick. The 3 is in the tens place, so I'm really doing 4 times 30. 4 times 30. And we know that 4 times 30, we've already solved that, is 120. All right, let's move on. Now I've got my 5 here. I'm going to multiply the 5 times the 6. But look, my 5 is in the tens place. So it's not really 5, it's 50. So I'm doing 50 times 6. 5 times 6 is 30, times 10 is 300. And then the last thing I've got is this 5. I'm going to multiply it by the 3. But if you look carefully, the 5's in the tens place, so that's really 50. And the 3 is in the tens place, so that's really 30. I'm really doing 50 times 30. 50 times 30, well, 5 times 3 is 15, times 10 is 150, times 10 more is 1,500. So I'm doing all the same work, I'm just stacking it up a little bit differently. Now I can add up my numbers. Oops, helps when I do my math right, huh? 2 plus 2 is 4. Phew, that's okay, we can revise our thinking. So I got the same answer. And the first time I did this, I thought, why did I get the same answer? But when I look, I can see the same partial products. Here, my first number, 24, is the same partial product that I had right here, because this had me at multiplying 4 times 6, and that's what I did here when I multiplied 4 times 6. My next partial product was 120, which I got from right here when I multiplied 4 times 30. 4 times 30, and I got that when I took 4 times 30. I took it the next digit over. My next partial product is 300, which I got from up here, which is 50 times 6, and I did that right here, 50 times 6. And you can see my last one. I bet you already saw it coming. That was my 50 times 30 for 1,500, and I got that when I did 50 times 30. So this method called partial products uses all the same numbers, all the same multiplication skills, but I'm showing it in less work. And I am going to continue with this later in the week to standard algorithm, where we don't even have to write this. It's going to get even faster and even simpler. But I want you to see where all these different numbers come from, because when we move into the standard algorithm, I want you to see what's happening. Take a second and notice where the partial products match up in this version versus our area model. All right, this week when we work on math for the next couple days, we're going to practice trying it both ways to build our confidence with this so that we're ready to move into standard algorithm. Thanks for joining me.